Welcome, students. In this session, we will begin with one of the most widely used sealing elements in engineering, the O-ring. O-rings are donut-shaped, also called toroidal sealing elements. Their main purpose is to prevent the leakage of fluids or gases between two mating surfaces. They are extremely popular because they provide low-cost sealing, they are reliable, easy to manufacture, and easy to install. Most importantly, they can work in both static conditions, where there is no movement, and in dynamic conditions, where motion such as rotation or reciprocation is present. O-rings are used in a wide range of engineering systems. Let us understand some applications. In static sealing, O-ring acts like a gasket. Like in pipe flanges, valve covers. In dynamic sealing, it acts like a packing. Like in pistons, shafts, and actuators. In pneumatic systems, it seals gases. Like in control valves, air cylinders. And in vacuum systems, it maintains vacuum in vacuum chambers. Whenever we select an O-ring, we must clearly specify the application type, such as pneumatic, reciprocating, or vacuum, rotary. This ensures correct material and design selection. Measurement parameters: O-rings are defined by three important dimensions. ID, inside diameter. OD, outside diameter. W, cross-sectional width or thickness. These dimensions help us understand how the O-ring will fit inside the sealing groove, known as the gland. When installed, the O-ring deforms slightly inside this gland and creates sealing pressure. Standard sizing system. In industry and defense systems, O-rings are often identified using the AS568 Dash Number system. Instead of writing actual size in millimeters or inches, we use a dash number such as -210 or -325. Each dash number represents a specific inside diameter and cross-sectional width. The dash number system also groups O-rings into categories based on cross-section size. This makes identification and selection faster and standardized. Material selection is critical for successful sealing. Different materials provide different resistance to temperature, chemicals, abrasion, fluid compatibility, and pressure. You can go through this table for better understanding. So remember this rule. Correct material selection equals successful sealing. Wrong material selection equals leakage plus premature failure. Static versus dynamic performance. Let us now compare static and dynamic sealing performance. In static, there is no movement and O-ring suitability is excellent. In reciprocating motion, where is short stroke and moderate pressure, O-ring is good to use. In rotating motion, but remember where the speed is low, is that less than 66 meter per minute, O-ring is acceptable. In high-speed rotation, where the pressure is high and backup ring is available, its use is conditional. At high temperature, where appropriate material is used, some specific O-rings can be used. Please note, rotary shafts must be perfectly round. O-rings cannot seal eccentric shafts. Importance of sealing pressure. O-rings seal using two types of pressure. Compression pressure, when the O-ring is squeezed inside the gland. Fluid pressure, which pushes the O-ring against the groove walls. For low pressure, below 6 bar, material softness and surface finish become very important. For high pressure, above 6 bar, harder materials and backup rings are required to prevent extrusion. Failure can happen due to mechanical reasons, environmental reasons, or aging. Mechanical causes: extrusion due to excess pressure, shaft misalignment, poor surface finish, overcompression during installation, twisting during fitting, scratches caused by sharp tools, environmental causes, chemical attack due to wrong material, temperature beyond limit, abrasive particles in fluid causing wear, UV light or ozone cracking the surface, aging and storage failure. Rubber degrades over time. Therefore, shelf life must be checked. Cure date and expiry date must be mentioned. Once installed, shelf life rules do not apply. Proper installation and removal methods. Things that can be done. Use soft plastic or brass tools. Lubricate with system fluid. Avoid twisting. Install gently in gland. Keep original envelope. Things that can't be done. Never use metal tools. Never install it dry. Don't elongate it too much. Don't pierce with nails or hooks. Never store it in open air. For inspection, gently roll the O-ring over a dowel rod. This reveals cuts, cracks, or defects. If damage is found, reject the O-ring immediately. Backup rings are used when pressure becomes too high for a normal O-ring. They prevent extrusion into the clearance gap, especially during reciprocating motion. It is required when pressure is above 110 bar. It is used as reciprocating piston seals when there is alternating pressure direction and to extend O-ring service life. Its types are solid or uncut ring, single cut or bias cut, spiral cut, which is best for dynamic applications. Always install on the low pressure side. If two backup rings are used, their cuts must be staggered. Materials. TFE or PTFE are most common and does not age. Leather are only in solid form and hard rubber. Oil seals are used when a shaft rotates inside a bore or housing. They have two functions. Prevent fluid leakage out. Prevent dirt and dust from entering the system. Design principle. There is a small clearance between shaft and bore. The sealing lip must face the fluid pressure side. Many oil seals contain a spring, which applies constant contact pressure on the shaft. Now we will go through advantages and limitations of some specific materials. Fluoroelastomer can be used at high temperatures, but it has poor low temperatures performance. Polyacrylate has good mineral oil resistance, but it is weak in cold conditions. Nitrile has good water or oil resistance, but has poor ozone resistance. Silicone has wide temperature flexibility, but poor oil and hydrocarbon resistance. Now we will talk about storage practices. What should be avoided and why? Do not expose to heat or sunlight as it can cause aging and cracking. Do not hang seals from nails as it can cause deformation. Never stack seals under weight as it can lead to flattening. Do not pierce packets as it allows contamination. Never store near solvents or oils as it will lead to chemical degradation. Then what can be done? Store seals in sealed packaging. Maintain room temperature. Use first in first out method. Keep storage area free from dust, UV light, ozone, and chemicals. Let's talk about some guidelines to be followed. Always select seals based on fluid type, temperature, pressure, and motion. Use correct dash number and gland dimensions. Inspect and lubricate O-rings before installation. Use backup rings for high-pressure applications. Oil seals must always face the fluid side. Avoid sharp tools during installation. Maintain proper storage and handling to prevent aging. Thank you for attending this session. Have a great day ahead.